Good morning. Today we are starting off our math binder. We are doing our unit 1. It's a trimester 1 binder. We are starting with CO1. That is our course objective 1. So up here in the corner is where you find where we're at. So we're at CO1. When we see a PO instead of a CO, that's a power objective. Those are the objectives that you have to pass. Every single PO throughout Math 6, we have to retake if we don't do well on a test for it in order to go on to pre-algebra next year. If it's a CO, just the course objective, we have to pass at least 80% of our COs. Once we take our first test, it'll make more sense what that all means. Just keep in mind the power standards that we had in 5th grade. Those were the super important ones that you had to try to master. Power objectives, same concept. That's the super important that we are trying to master. So today we are doing CO1. I can describe integers, compare integers, and identify an integer's opposite and absolute value. So in order to be able to do those things, we need to understand what they mean. So we're going to write down some definitions. So everybody needs to have their pencil out. And what I write on the board, you write on your book. Okay? So as I'm writing it, you're writing it. Same thing. I always have some kids that'll just write a little bit of what I write. And they go, oh yeah, I get it. I understand. And then in a couple of weeks, we have to review what was on this page, and we come back to look at the review to remind ourselves what an integer is, and we find out they didn't write all the words down and it doesn't make sense to them. They didn't put the examples that I put. They're missing stuff, and it doesn't help them study for the test. It is super important that you write everything that I write, where I write it. Okay. It will help you when it comes to time to study for the test. I'm not saying this because I want you to do extra work. I'm not saying it because I want your hand to cramp up because you're having to write stuff out. I'm saying it because I've taught math for many years. And I've taught this math ever since I've been at St. Vincent. And I know what really helps us. Okay? And I want you to be the most successful when it comes time to take the test. So truly, what I write on the board, I need you to make sure is in your binder. So the first one is an integer. An integer is a positive or negative number that is not a decimal or fraction. So an integer can be positive or negative, but it cannot have a decimal point with numbers after it. It cannot be as a fraction. The absolute value is the distance of a number from 0. And opposite numbers are two numbers. Helen, are you able to see okay from that angle? Okay. It's the first time I've had these desks in this room, so just making sure we're at places where we can fully see. And Etta, the podium's not blocking your way. Okay. All right, two numbers that are the same distance from 0 they have the same absolute value. Now some of these are new words for us, and we're going to go through what that means. It's one thing to write down the definition, and it's another thing to really understand what that definition means. So let's make sure we have our definitions written down, and then I'm going to walk us through what they mean. So the first thing we're going to do is we're going to make a number line below that ranges from -12 to 12. So I'm going to make my number line. Because it's a number line, it goes on forever, so I'm going to put my arrows at the end. In the middle, I'm going to put my 0. Because I need to have negative numbers and I need to have positive numbers. My negative numbers are always to the left of the 0. Positive numbers are to the right of the 0. And it wants us to go all the way to -12. So I'm going to say this is -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, -11, -12. Then I'm going to go do the same thing with my positives. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we don't have to put every single number on there. We can just count those marks to know we should have 12 marks going out to the -12, 12 marks going out to the +12. So the further to the right, as we go this direction, the further to the right a number is, the blank its value. Do you think it's going to be greater or lesser? Bridget? Yeah. The farther to the right we go, the bigger it gets. So the greater its value. So as we go to the right from 0, it gets bigger. It's greater. So now think about it. The further to the left a number is, Lexi? The lesser its value. So as we go to the left, it gets smaller. So those negative numbers get smaller, smaller, smaller. So a -100, 100 sounds huge, but it's actually really small. Think about on our thermometer when it gets cold. When it's -40 degrees, oh my goodness, that is super cold. We stay home from school. So the colder it gets, the smaller that value is. Right? If it's 90 degrees out, that's super warm. Sun's shining. We're hot and sweaty in the classroom. Right? So if you're ever trying to remember what gets bigger, what gets smaller, think about our thermometer. Think about those temperatures that we know. The colder the temperature, the smaller it's getting. The hotter the temperature, the bigger it's getting. It's pretty easy to mistakenly think that -10 is greater than -8 because we think 10 is bigger than 8. Think of the number, that's what I just went through. Think of the number as that thermometer. Okay, so when we make a number line, it's easy for us to compare those numbers. We can look at those integers, we can look at the absolute values and the opposites using that number line. So we're going to use that number line. Let's do a couple of examples before we do the bottom ones. So let's say, change up colors. These numbers, the negatives and the positives, As long as they are those solid numbers, there are no decimals and no fractions, it's gonna be our integer. How do we find the absolute value of our integer? The distance of the number from 0. So if I have 1, 2, 3, 4 is right here, 1, 2, 3, -4 right here, what is the absolute value of my 4? Adeline? 4. Because we count back. To get to 0, it's 1, 2, 3, 4. So the absolute value, we show absolute value by a line in front and a line behind the number. When we say, what's the absolute value of 4? That equals 4. What if we want to know that absolute value of -4? What's the absolute value of -4? James? 4? Let's count it. How many away from 0 are we? 1, 2, 3, 4. So the absolute value of -4 is going to be just 4. So the absolute value is never going to have a negative sign. It's just how many jumps does it take to get to 0. We're either jumping to the left or we're jumping to the right. But it's always going to be that positive number. So that's the absolute value. How far away? How many jumps to get to 0? Opposite numbers, two numbers that are the same distance from 0, they have the same absolute value. So if we look at that 4 and the -4, they both have an absolute value of 4. So the opposite is going to be the positive and the negative of the same number. So 4 and -4 are opposites. They're the same distance away from 0. How are we feeling about that? Show me your thumbs. Feeling okay about, some of us are like, okay, I'm kind of following. We're going to do some examples together to help it really sink in. So I have to erase what I put up here so I can scroll up. So we can easily compare the values of the numbers by plotting them on that number line, like I did with the 4 and the -4. Let's look at 9. Determine whether each number is an integer. So what can it not be? Adeline? Can't be a fraction or a decimal. If it is not a fraction or a decimal, it's not an integer. Okay? But we can look at if it has what its absolute value is and what its opposite is. So the first thing we're going to do to decide, is it an integer? Is it not an integer? Then we're going to put down our opposites and our absolute values. So if we look at 9, is 9 an integer? Yeah, because there's no decimal and no fraction. So we're going to write integer. Then we need to decide what its opposite is and what its absolute value is. So if we have 9, what would its opposite be? -9. They are both 9 hops away from 0. What is its absolute value?
9.
9. Absolute value is always going to be positive. 9 hops away from 0. Let's look at -3.2. Is that an integer?
No.
Why not? Nolan?
There's a decimal.
There's a decimal. So it's not an integer. So I'm going to put not integer. You put no to the integer. Bennett?
We put N-E
Why N-E?
and I.
Right, no. Then, but we still need to put what its opposite and what its absolute value is. What would the opposite of negative 3.2 be? Ma'am?
Positive plus 3.2.
A positive 3.2. What is its absolute value, Lila?
3.2.
3.2. That's how many hops away from 0 it is. So the absolute value will always be positive. The opposite is going to be the opposite of the original number. If it's a positive, its opposite will be negative. If it's a negative, its opposite will be positive. Well, let's do another one. 4/5. Is that an integer or not an integer? Kelly. Why isn't it an integer? Because it's a fraction, not an integer. But I need to find its opposite and its absolute value. What is the opposite of 4/5? Gemma?
Negative 4/5.
Negative 4/5. And what is its absolute value? Emerald? 4/5. One more together. Let's look at our negative 6. Emma?
Integer.
How do you know it's an integer, Emma?
Because it's not a fraction or decimal.
It's not a fraction or decimal. What is its opposite? Alyssa?
6.
A positive 6. And what is its absolute value, Maddie?
Positive 6.
Positive 6. You are going to finish this page on your own, but we have a second page we have to do, and I want to go through those directions. So we're not going to finish it at this moment. We're going to have work time as soon as I explain our second page. Sometimes we just have one page, sometimes we have 2 pages. This is a 2-pager. Let's look at those directions. Circle the greater integer. Check your answer by plotting the numbers on a number line. So I'm going to look at my 4 and my 10. And I'm going to say, okay, on my number line, I know the 4 is on the left, the 10 is on the right. It's a positive number, it's going towards the right. So which one is my greater number? The 10. Because as we go to the right, it's the bigger number. So you have to circle the greater number, and you have to do all the directions. It says draw that number line to really show it. So if I look at this next one, I have my number line. I know negative numbers are on the left and positive numbers are on the right. Which one is a bigger number? Which is my greater number? Nolan?
6.
6. Let's do one more together. With my negative numbers, I know that if 0 is over here, my negative 9 is going to go there, and negative 11 goes this way, because my negative numbers, I go all the way to the left. So which one is the greater number? Kylie? Negative 9, because it is the one on the right. Okay? So you need to draw those number lines. You don't have to put every single number on the number line. Just figure out where your 2 numbers are going to go on that number line. Look at which one's on the right, that's the greater number. Okay? Any questions on this section? All right, let's look at the middle of the page, or the bottom half of the page. We have word questions. Which is greater? 15 or the opposite of negative 17. What I do when I do these word problems, because sometimes when I do stuff in my head, I go too fast and I make simple mistakes. So I always write out, and you'll see it when I show it, I always write out what it is. So 15 is 15. The opposite of negative 17 would be what, James?
17.
17. So I'm going to write a 17 there, because that's what the opposite of negative 17 is. So now I'm going to compare my two numbers. Which is bigger, 15 or 17? What do you think, Jack?
17.
17. Or actually, I take that back. I'm not going to write 17 because I have to put opposite of negative 17. So I have to go back to the original number. Okay? So I can't just put 17 because it's 15 or opposite of negative 17. 17 wasn't an option. So I have to go back and say, the opposite of negative 17 I know is 17, so opposite of negative 17 is greater. That's what I'm going to write for my answer. Did you have a question, Adeline?
For this one of them is equal, so which one do you do bigger?
Let me scroll back. Which one?
So these two are equal.
What are the two numbers?
100 minus 112.
And what's the other number?
Negative 100.
Is it?
Negative
Careful. What's in the tenths place there?
Oh.
It's a 2. They are not actually equal numbers. They look very, very similar, but if we look at that tenths place, there's a different number. So one is negative 112, but the other one's negative 122. So that's a great question. When you come to something, you go, well, wait, they're always going to be less than or greater than. This one's equal. Really look at it and check and say, if it doesn't make sense, I'm seeing something wrong. So that was a great way to learn that. James?
I have a question.
Yes?
If you want to do this at home on your computer, could you just send the word to us and then we can do it on the computer?
Math we don't do on the computer. Math we're going to work it out because when we get to more challenging math, it's very, very hard to do it on the computer. So no, we will always do this in the binder with your pencil. Okay, that's a good question. Gemma?
There's one that's 0 and negative 1.
Okay. So if I draw my number line, where would I put the 0? On this side or on this, the left or the right? Where would I put negative 1?
Left.
Can I figure out which one's greater? It's always going to be the number that's on the right. Seems weird to say 0 is a greater number, but just remember those negative numbers are all smaller than 0. So when we're at 0 degrees outside, it's cold. We wear our jackets and we wear our hats and our gloves because it's chilly. Warmer than negative 40 degrees. So it seems weird to do it, but that's why we do that number line to help us go, oh yeah, I guess that really does work out that way. Any other questions on today's assignment? So you have to finish that front page, the bottom of the front page, and you have to do all of that second page. We have work time in class now. We've got 12 minutes before we're changing classes. That doesn't mean we rush to be done and just slap down numbers. We do our best work. Sometimes we will have homework in math, sometimes we don't. Sometimes we're able to get it done in class. We don't ever rush because we're not going to learn our math if we don't take our time. Now is the time where you'd be able to come up and ask me individual questions if you're not sure about something. If you get to a problem and I'm not at the board anymore and you go, well, wait a minute, how do I work this one out? Now is the time that I work with people one-on-one. Sometimes I will sit at that back table and people will be able to come to the back table to work with me during that time. Sometimes I'll be up at my desk and you can just come up and ask me the questions. This is a calm, quiet work time, but it doesn't have to be silent. If you have a question that you just want to ask your neighbor, because it's a little question, you can ask a neighbor a little question. We don't ever just give answers to our friends, because then they don't learn. But you can do stuff like I did, where you say, well, let's draw the number line and see how do we work that out. So you can show them how you're solving the problem without telling them the answer. Okay? I'm okay with us helping one another. I'm not okay with us just giving answers. Bennett. All right, so with that, I am going to sign off of the recording. If you're watching this at home, I hope you are well, and I hope to see you soon. Don't forget to like and subscribe to my channel.